All right, so today I want to just talk briefly about inverse trig functions. Basically, that's 7.5, I think it is in your text. Taking the integrals and derivatives of them. So if it's been a while for you, remind you that y equals the arc, or y equals the sine of x. So that's this guy forever and ever ad infinitum. If you wanted to do the inverse sine, this function would have to be, first of all, it'd be 1 to 1, right? So we need to take this sine function and we need to make it so it's 1 to 1. So what we would do is we'd lose all the extraneous business and we'd go from negative pi over 2 to pi over 2, and it would be 1 to 1. You go from negative 1 on the low end, positive 1 on the top end. And when we flip it around, what we'd end up with is, that's sine. This is arc sine, would be this fella. Whoop, whoop. And it would go over here to positive 1 and negative 1, and it would go up to pi over 2, which is about 1.5, down to negative pi over 2, which is about negative 1.5. And there you go. Now then the question is, of course, back to Calc 1, how do you take the derivative of this guy? So y equals arc sine of x. Well, what you need to do is you need to take and do implicit differentiation. So the derivative of the sine of y is the cosine of y dy dx is equal to 1. Because you take the derivative of x, you get 1. And then dy dx is 1 over the cosine of y. And then, well, what is the cosine of y? Well, I don't know, but I know that I have an angle y. And I know that his sine is x over 1. So this must be 1 minus x squared. And so if I do this, 1 over cosine is the same as saying secant, which is hippopotamus, over adjacent. So there it is, baby, and you're home free. Okay, that would be the derivative of it. Ditto on the arc cosine. Right, so if you had this fella, then that means x is the cosine of y, and then 1 is equal to the negative sine of y dy dx, and so you end up with negative 1 over the sine of y dy dx. Similar triangle, obviously somewhat different, but not quite. X over 1, square root of 1 minus x squared is on this side this time, and so it ends up being negative 1 over this fellow right here, which probably doesn't shock you because it's like the negative what I just had, and the derivative of cosine is negative sine, so you're kind of like, well, that makes sense. Kind of. Arctan, similar story. Again, this is all review-ish, should be for you. If it's not, walk with me on it and we'll figure it out for you. So the derivative of tangent is secant squared y dy dx equal 1. Dy dx equals cosine squared y. Yes? This is the triangle this time. Like so. So that if you look at this guy right here, it's going to be 1 over this guy squared, or in other words, 1 over x squared plus 1. That is the derivative of arctan. And that's all fine and good. Now, Grim, we're not doing derivatives, we're doing integrals. Oh, I know, right? So check this on me, bro. If you want to do the integral of, I'm going to do arctan first, if that's okay. Well, I don't care if it's okay. I'm going to do it anyway. The integral of arctan of x dx. Okay? Now, first things first. This looks like a product to me. Wait, you mean integration by parts? Yeah. Wait, but integration by parts, we do log. This is the order we do use because we hate doing derivatives, or integrals rather, on hard things. So, logarithms, hard to integrate. Inverse trig functions. Oh, there you go. I'm not going to integrate it. I'm going to derivate it. And then dv is dx. And then du is, of course, 1 over x squared plus 1 dx. That's hot. And so if you do this, you get uv, right, minus the integral of v du. And so if a feller does that, what you'll see is you have x arctan x minus the integral of x over x squared plus 1 dx. And you're like, oh, that's awesome. What do I do on this one? Well, it looks to me like I've got a function, x squared plus 1, in a function that is just 1 over that. But what about the x? Well, just sit tight, friend. du is 2x dx. That means I have half of a du. Half of a du is an x dx. So I have x arctan x minus the integral of a half of a 1 over u du. So x arctan x minus 1/2 ln of x squared plus 1 plus c. That's our guy. That's our guy. And then we're home free, baby. If you don't believe me, can I take the derivative? Yeah, that's a product rule. So it's arctan x plus x times 1 over x squared plus 1 minus 1/2 times the 1 over that, so 1 over x squared plus 1 times the derivative of the inside, which is 2x, cancel. Yeah, and then this and this are the same, but with different signs, so cancel, and you're left with where you started from. It better work out, otherwise you screwed it up. Arc sine x, same thing. Here we go. So u is arc sine x, dv is dx. I'll do the hard part. Okay, crap, I have to do the easy part too. Whatever. It's 1 over squirt 1 minus x squared. Right? Right. So x arc sine x, right, minus the integral of v du, x over 1 minus x squared, squaricated. Well, to me, that looks an awful like u is 1 minus x squared, du is equal to negative a half of a dx, I guess, of an x dx. Yeah, that looks right. Did that in my head. Wait, so that means I'm going to have x arc sine x plus 1/2, and then it's going to be 1 over, well, it's going to be u to the minus half, so it's going to be u to the minus a half du. And so x arc sine x plus, and then if you take the antiderivative, you're going to get u to the half times 2, and there's a half out front. Is that right? And then so you're going to x arc sine x plus u squared. But what is u? U is that thing. I'm sorry, u to the, not to the square. You dumbass, the 1/2. So u to the 1/2, which is just 1 minus x squared plus c. And that is the right answer. Nice. I think cosine's pretty straightforward. It's the same thing. What would happen if this was, what would happen if there's a 4x in here? Not much, really, honestly. 4x. What would it, so what? There would be a 4 floating around in this thing all the way through it, right? That makes sense. There'd just be a 4 floating around in the thing. And you'd have to do a little extra substitution to do this, is all you'd have to do differently. It wouldn't change anything. Not very hard to do. Okay. That's basically it. It's not very hard. They are, once you've seen them, you can't unsee them. They're just not very difficult at all. Yeah, I think I'll leave cosine for you. What the heck? Let's do cosecant for fun, shall we? If you have the arc cosecant of x, gross. Of course, that means that the cosecant of y is x. Wait a minute. Here's y. Cosecant is x over 1. So this is x squared minus 1. That sounds about right. Take the derivative here. That's going to be negative cosecant cotangent dy dx. And so that's dy dx equals, well, it's going to be 1 over cotangent, which is tangent, and 1 over cosecant is sine. Negative. Yay! What is the tangent here? The tangent is 1 over square root x squared minus 1 times the sign is 1 over x. So in other words, it's going to be negative 1 over x square root of x squared minus 1. I say that because, of course, we're going to have to use it momentarily. So if you want to take the integral of the arc cosecant, because obviously, then u is arc cosecant, dv is dx, du then is, of course, that mess. Well, couldn't I just look it up in that table? Well, bro, you could do all this crap. You just type it into the giggle chats. I don't know, but that's not the point. So, oops, v is equal to x. I'm sorry. There we go. So, x cosecant inverse of x minus, but it's going to be minus and minus, so plus x over x square root x squared minus 1 dx. And so you're left with that. And you're left with that. Just a sec. All right. I'm sorry, I'm back. So that's trig substitution, right? That's what that guy is. Remember that back in the day? About a week ago? Sweet. So let's let x equal 1 secant theta. So dx is secant theta tan theta, d theta. And so x cosecant x plus, so that's going to be 1 over secant squared minus 1. And then on top we're going to have secant theta tan theta d theta. Secant squared theta minus 1 is tangent squared. The square root of tangent squared is tangent. The integral of the tangents cancel out, and you're left with that plus the integral of secant theta d theta. That is one you can use a table for. I don't care. I'll probably have that on the board when we do this problem on the test or something similar to that. The integral of secant, where are you? The integral of secant is, should know off the top of my head. The integral of secant is, where are you people when I need you? I can't find it. Gee, it's right there staring you in the face. Well, it probably is. No, it's right there. No. Why? I see cosecant. Why don't I see secant? There it is. It's the ln of the secant plus tangent. This is the integral of secant of theta. D theta is the ln of the secant of x plus the, or of theta rather, plus the tangent of theta. Okay? Well, what's theta? Remember this picture right here? It says the secant of theta is x over 1. So this side is x squared minus 1. Again, if you don't get that, you screwed up. So then this is going to be x cosecant x plus the ln of this. I'm going to write it this way first. Oops, no d theta anymore, Jay. So x arc cosecant x plus ln of the secant. Well, the secant of theta is, secant is x over 1, so just x. Plus the tangent would be x square root of x squared minus 1 over 1. So just that plus c. And then you're home free, baby. That's the antiderivative. Boy, wasn't that a good time. Okay. Anyway, that's mostly what we're doing. I will have things like this thing on the board when it comes to test time. This will be on the final, not the current test. I will have a few of those written out for you, or I will have a piece of paper that you can access for those on the test.